In 3D objects, the absence, the region where the mass is absent is called as a cavity. No. Okay, work out here now. So what is the assumption has to be done here? So this particular structure, what we assume is it is equal to cone, solid cone, scene diagram. Let me adjust this structure. It is not coming. No, okay. Everything is a solid. It's a solid cone. Are you getting? No. Now I am going to remove a solid hemispherical region in this. Then it will become a solid cone with hemispherical cavity. So this is the this. Let me shade it here. When I put this negative density hemisphere in that solid cone, so definitely what do I expect? The positive density, negative density will cancel out, and finally what do we get? We get a solid cone with cavity. So what is this? Solid cone with cavity. Solid cone without cavity, and this is the solid hemisphere of negative density. Hope are able to get this. So what we know, we have to calculate this mass m1 and m2. These things are needed. Directly the given density. So how to get the rho? Now first, what is m1? m1 should be equal to volume of the cone, rho pi r square h by 3. What about m2? Minus rho. Why negative? Because there's a absence of mass, no? When I keep this here, plus density, positive density, negative density, the material will cancel out, then we'll get this a cavity here. So this is the cavity. Now this should be 2 by 3 pi r cube. Let's get into the YCM is equal to m1. What is the center of mass of solid cone? From the base, from where we are measuring, we are measuring, this is y equal to 0 from here. This is x-axis. Just now we have studied, no? I think, see, these are the numericals. Nobody will ask you to derive center of mass of cone. The application problems like this, if you don't know center of mass of solid hemisphere or solid cone, I don't think so in exam you can really manage anything. H by 4 from the base, 3h by 4, 3h by 4 from the apex. From the base it should be h by 4. Like this, see, why I suggest you, see, memory of what kind? Memory of this standard derivations. What all we learn, no? So those things you should be able to analyze and remember. What is h? We don't know h. H is nothing but 3r by 8, no? This only I'll call h. Okay, this will be by m1 plus m2. Somebody please mute it. Okay, now substitute all the values. What is m1? I'll push these things here. Okay, now we'll go for calculation. m1 rho pi r square h by 3. This is h by 4. m2 is minus rho 3r by 8 m1 rho pi r square h by 3 minus rho 2 by 3 pi r cube. What is h? H is given, no? 3r. Substitute and solve it. Anybody give me answer? H you have to substitute 3r. So rho pi r square will anyway will get cancelled. Check it. Rho pi r cube will get eliminated. Let me go for it. Rho pi, now present rho pi r square by 3, I'll take it out. So I'll be left over with h square by 4 3r cube r square, sorry, divided by rho pi r square, we have taken out that h minus 2r. So what is h square? 9r square by 4, 3r square by 4, h is 3r minus 2r. (1.5r). Check once calculation.
(1.5r), sir.
Yeah. So now in any object I can remove any other shape, no? So you have quite independence are there rather than fighting with the book, no? Just like take some solid object, in that you remove some well-defined geometrical shape, then where center of mass can be. So it will be somewhere at this particular point, it will be 1.5r. Center of mass, no, you just indicate this is C1, C2. Center of mass of this solid cone with cavity, with hemispherical cavity, will be at a half of the height. Now scroll down, we'll take the next one. Now I can have a more than one object